Hi everybody, welcome to day 3. Today we're going to be starting to talk about quadrilaterals. So as part of our polygon chapter, we're really going to dive deep into this quadrilateral idea. So we are going to just take a quick look at the beginning of our quadrilateral family tree so you kind of have an idea of where we're going to head here. So quadrilaterals are any four-sided polygon. So it can have convex, concave. We're going to be looking at four-sided polygons. Specifically, we're going to be looking at convex quadrilaterals. So quadrilaterals can be broken down into 3 groups. We have kites, parallelograms, and trapezoids. So we're going to start off on this thread of parallelograms, and then eventually we'll get to trapezoids. Now, kites do exist. We are not going to be talking about them in this chapter, but I just wanted to let you know that what they are. So a kite is a four-sided convex polygon. So a convex quadrilateral that has 0 pair of parallel sides. So it kind of looks like the kite that you were drawing when you were in kindergarten. So one thing that is true, not only does it have 0 pairs of parallel sides, but the adjacent sides, the ones that are right next to each other, are going to be congruent. So like these two might be short and those two might be long. The 2 short sides would be congruent, the 2 long sides would be congruent. So that's just fun fact. So you're not going to be tested on that or anything. But we are going to be talking about in-depth parallelograms today. So if you get your notes out or get your note sheet in front of you, we're going to start talking about parallelograms. So parallelograms actually have, I needed to change this, 7 properties. Now 2 of those properties come from being a quadrilateral, and then it has 5 properties of its own that are specific just to parallelograms. So the 2 that come from it being a quadrilateral. Well, first of all, let's remind ourselves what a parallelogram looks like. Parallelograms, just in general, are going to look kind of like this. So kind of like a rectangle that's been shoved over a little bit. But because this is a quadrilateral, what does that mean is true? Well, quadrilaterals have 4 sides, so it's going to be a 4-sided polygon. Oops, 4-sided polygon. So all parallelograms will have 4 sides. Now, because it does have 4 sides, that means the angles, do you remember quadrilaterals, the sum of the interior angles, which we were doing yesterday and the day before? So the sum of the interior angles, so if we were to add all 4 of these angles together, do you remember what they add to? So the sum of the interior angles is 360 degrees. Now, this isn't because it's a parallelogram. These 2 are just true because it's a quadrilateral. So just to remind you, that 360 comes if we divide that parallelogram into 2 triangles. That's 180, that's 180, and that's where we get that 360 degrees from. Now, there are 5 properties that are unique to a parallelogram. So because it's a parallelogram, what is true? So I'm going to tell you what they are here, and then we're going to draw pictures next to each one as well. So the first one we're going to talk about is the definition. What defines a parallelogram? So when you see a 4-sided shape, how do you know for sure it's a parallelogram? So in order for you to know for sure something is a parallelogram, do you remember what the definition is? It must have 2 pairs of parallel sides. So the opposite sides are going to be parallel. So to mark them parallel, we put the arrows in the middle. So since these 2 are parallel and these 2 are parallel, I do need to put different marks on them, but arrows will be what I use in the middle. So we're going to have 2 pairs of parallel sides, and they're going to be the opposite sides, which are parallel. So you might remember from over here, a kite has 0 pairs of parallel sides. So that means we know a parallelogram has 2 pairs of parallel sides. So then by default, what do you think a trapezoid has? So when we get to that, we'll be talking about how this has 1 pair of parallel sides. All right, we'll get to that. Don't stress about that yet. All right, so what defines a parallelogram? When you're looking at a quadrilateral, you know for sure it's a parallelogram if the opposite sides are parallel. If you don't know that both are parallel, then you don't for sure know it's a parallelogram. You can assume but we need to know for sure. So they either need to be marked parallel or we need to be told they're parallel. Now, these other four are just properties. So because it's a parallelogram, what else would be true? So it's going to have opposite sides, not only parallel, but they're also congruent. So if we have our parallelogram, top and bottom here would be congruent, left and right would be congruent. So opposite sides are parallel, opposite sides are congruent. Now let's talk about the opposite angles. The opposite angles are congruent. So which ones are the opposite angles? Opposite angles are the ones that are across the parallelogram from each other. So in this case, A and C are opposite, so A is congruent to C. And B and D are opposite because they're on opposite sides of that parallelogram, so they will be congruent to each other. All right, opposite angles are congruent, opposite sides are congruent, opposite sides are parallel. Now the diagonals. The diagonals bisect each other. All right, so the diagonals are the segments that go from opposite corner to opposite corner, opposite angle to opposite angle. So the diagonals bisecting each other means they're going to cut in half. So they're going to cut each other in half. So this short diagonal is cut in half by the long diagonal, so its two halves are congruent. And the long diagonal is cut in half by the short diagonal, so its two halves are congruent. Now, if you notice, this point right here is where it's cut in half. So when the diagonals bisect each other, that means they have the same midpoint. So the diagonals have the same midpoint. That's another way to say this. Sorry, I like to abbreviate a lot, so I will use symbols a lot. I will shorten words a lot. So MDPT, that's midpoint. Angles, congruent, parallel. So I'll do my best to make sure I say them out loud as I write them. All right, the last one is about angles again, but instead of opposite angles, we're going to talk about consecutive interior angles. So the consecutive angles. Consecutive interior angles. All right, so this vocab you may not remember. Maybe your teacher used the word same side interior instead of consecutive interior. But we're going to be looking at the angles that are next to each other. So A, B, C, D. Consecutive angles would be A and B. So angle A and angle B are consecutive. Angle B and angle C are consecutive. So angle B and angle C are consecutive because they're just next to each other there. Angle C and angle D are consecutive. They're next to each other. Angle D and angle A are consecutive. They're next to each other. Now, this property actually comes from the definition. So, because the opposite sides are parallel, these consecutive interior angles, if I look at A and D, two parallel lines, this is my transversal. My consecutive interior angles, my same side interior angles, will be supplementary, which means they're going to add to 180. Now, because I have so many pairs, all of these sets are going to add to 180. So A and D will add to 180 because there's your parallel lines, there's your transversal. B and C will add to 180, they're consecutive interior because here's your parallel lines and there's your transversal. But don't forget these ones are also parallel. So if these two are parallel and that's your transversal, then A and B are consecutive interior, so they'll be supplementary. So we have a lot going on with parallelograms. We have two properties about sides, they're parallel and congruent. We have two properties about angles. Opposite angles are congruent. Consecutive interior angles are supplementary. Not congruent, but supplementary. And then the diagonals bisect each other. All right, so we're going to put all of this into practice now and see what we can do with this information. So let's look at example 1. In example 1, we have a parallelogram. So it should have been marked parallel. I'm going to tell you it's a parallelogram, so I'm going to put my parallel marks on there. All right, so what do we know? We have a bunch of opposite sides. So according to our properties, we have two properties about sides. The opposite sides are parallel and the opposite sides are congruent. Now don't forget, congruent means they're equal. Now parallel is not going to help us find a length, but congruent and equal can help us find a length. So if we look at this, we've got two sets of opposite sides. So this opposite side should be equal to that opposite side. So 6x minus 12 is going to equal 2x plus 36. But we have another set of opposite sides. The top and the bottom are also opposite. So we have 4y equals 6y minus 42. All right, so this is because opposite sides are congruent. We know that these two equations should be true. All right, so pause the video and solve these two equations. All right, so you can see that I just did that work. It probably magically appeared on your screen. So I subtracted 2x from both sides and added 12 to both sides to get 4x equals 48, divided both sides by 4 and got 12. And then on this side, I subtracted 6y from both sides to get negative 2y equals negative 42, and then divided both sides by negative 2 and got 21. Now, those were not the only ways you could have solved this. So no matter what you did, you still should have gotten x equals 12 and y equals 21. And if you did, awesome. All right, let's look at our next problem. All right, so we have another parallelogram here. I'm going to mark it parallel so I know it's for sure a parallelogram. That's our definition. This time I don't have sides, but I do have RW drawn in and DE drawn in, and those are diagonals because they're going from opposite angle to opposite angle. And if you remember from our properties about the diagonals bisect each other, which means they're going to cut each other in half. So the two halves of those diagonals are going to be congruent. So this guy and this guy will be congruent, and this guy will be congruent. So we're going to use the property the diagonals bisect each other. All right, so if the diagonals bisect each other, what does that mean? So we already have them marked congruent, so that means x plus 2y is equal to 6. Now, this would be great if they were both x's or both y's, but I can't solve this right now because I have two variables. In order to solve two variables, we need to have two equations, and we don't have that yet. Now, here's one piece of information that I haven't used yet, though. We know that RW is equal to 30. So RW is this entire length here. So this whole thing is equal to 30. How does that help us? Well, if this guy is 5x minus 8 and this guy is 5x minus 8, right? Because they're congruent. So one thing we could do is 5x minus 8 plus 5x minus 8 equals the whole thing, 30. So that's a little segment addition. Or if you wanted to write it a little shorter, you could do 2 times 5x minus 8. So that's one option. Now here's the other option though. If you know the whole thing is 30, but the diagonal is cut in half, wouldn't this half have to be 15? So the other thing we could do is we could just do 5x minus 8 equals 15. Now either one of these equations we can solve because they both have one variable. And actually if you solve this one, our first step could be to divide by 2, which would give us this guy here. So if I add 8 to both sides, 23, and divide by 5, x equals what? Is that 4.6? All right, so if x equals 4.6, now we can plug that back in up here to help us find y. So please note that your variables aren't always going to equal whole numbers. Sometimes you'll get a decimal. That's okay. So if you're not sure if it's right, just take this, plug it back in, and see if it gives you 15. So let me do that here on my calculator. I'm going to do 5 times 4.6. That's 23, and then we're going to subtract 8, and that gives me 15. So I know for sure that's the right answer. All right, so now I'm going to take this, and I'm going to plug it into this problem. X plus 2y equals 6, so I can find y. So 4.6 plus 2y equals 6. So I'm going to subtract 4.6 from both sides. I get 1.4 and divide both sides by 2, 0.7. All right, so we wanted to find x and y. We did that. So x was 4.6 and y was 0.7. All right, last example here. We've got another parallelogram. We are going to find x and y again. So let's take a look at what we have. So this time we have angle measurements. So let's look at our angle measurements properties. So we have a couple. We have opposite angles are congruent, and we have consecutive interior angles are supplementary. All right, so let's see which one of those will help us. So opposite angles are congruent. Opposite angles congruent. And we have consecutive interior angles supplementary. Okay, opposite angles congruent would mean S and R are congruent, and I and K are congruent. So if we were going to write an equation for that, so we know angle S is equal to angle R. So that would be 35 is equal to 4x plus y. Well, this equation kind of puts us back in the spot that this one did from before. We have two variables, and we can't solve that quite yet. So we need to think of another strategy. For I equals R, 8x minus 25, this would also be 8x minus 25, so we could definitely do that, except if we set those equal to each other, angle I equals angle K, 8x minus 25 equals 8x minus 25, well, a whole bunch of stuff is going to cancel out here if we try to solve that. So because these two sides are exactly the same, this isn't going to help us. All right, so opposite angles congruent aren't exactly going to help us. So let's see if we can figure out consecutive angles are supplementary. So that means S plus K would equal 180. K plus R equals 180. R plus I equals 180. I plus S equals 180. So we can set any of those sets equal to 180. Let's see the ones, if we can find the ones that are going to help us solve this equation the easiest. So if I do I and R, if I add these two together, we're going to have x's and y's in our equation. So that's not going to be super easy. If I add together I and S, that's only going to be x's in our equation, so we can actually solve that pretty easily. So if we know that angle I plus angle S has to equal 180, because consecutive interior angles are supplementary, then 8x minus 25 plus 35 should equal 180. And this equation only has one variable, so we can solve it. So 8x plus negative 25 plus 35 is 10. Subtract 10, 170, divide by 8. 170 divided by 8. 21.25. All right, so if that's 21.25, we can check that by plugging it back in. Now we can use this equation though, because now we know x, we can use that to find y. So 35 equals 4 times 21.25 plus y. So 4 times 21.25 is 85. So then we can subtract 85, and y is going to equal negative 50. So how is it possible that y can be negative? Well, in this case, y isn't representing the entire angle, it's only representing part of it. So if I plug negative 50 in, I still get a positive angle because x was so big. So like when I plug this back in here, 4 times 21.25 minus 50, because it was negative 50, gives me 85 minus 50, which is equal to a positive angle measurement. So your variables can be negative as long as when you plug it back in, your angle is still positive. All right, if you have questions about this, please send me an email. Or if you have questions about your homework after you try it, please send me an email or contact me. Otherwise, have a fantastic day.